Добрый вечер. Меня зовут Sebastian Daschner. Я работаю в качестве евангелиста программного обеспечения для IBM. И я учу русский немножко, но я плохо говорю, so I think it's easier if I talk in English. I hope that is okay. Okay, so hi and welcome to this talk, or the two talks to this evening on how to get better as a developer. And this topic specifically how to, well, come up with design principles for effective development, to get better at designing, to get more effective as software developers. And about myself, so that's my name, and I do a lot of things related to Java. So I work for this company called IBM, and usually I work on the enterprise Java side, and I've seen a lot of enterprise projects, and I care a lot about Java and programming in general, enterprise software, but this specifically is about design principles and what design principles we should care about. So maybe if you studied computer science and you learned a lot of design principles, a lot of patterns, maybe learned them by heart or by some book, and you might have asked yourself, is that important? Do we need all this if we write some actual code, if we work in some projects? And specifically, there are many different design principles, or groups and categories of design principles. You might have heard of Gang of Four patterns, or the book. That is quite famous, and many principles that came based on that. We will have a look at the solid principles. Don't repeat yourself, or duplication is evil, try and die patterns, or domain-driven design, and many others. You can invent your own if you like. So the question now is, what of that is important? What should we care about in projects to come up with effective development, and especially with readable and maintainable code? So I hope we all agree that this should be the main goal. And one of the most important principles in computer science or in IT, regardless of all of these, is actually this: abstraction. Why abstraction is the most important thing in technology in general? Because it helps us to understand things and it makes our life easier. So probably, I don't know, you have a computer science background, or you studied IT, something like that. I studied computer science, and I've done a lot with computers, but I probably could not build a computer on my own, at least not using, silicon chips and soldering, your own things. I don't quite know how the electromechanics work, right? Like which electrons are being sent over the wire and things like that. I did not study, electrical engineering or something like that. But the good news is I don't have to. Right? Why? Because that is the most important principle. All of that is abstracted away. Up until the point that, you have things like this, that's a smartphone, and my mom, who has nothing to do with technology, she can use a smartphone, right? And probably, other people who are not related to tech, they can use a computer. Why? Because all of the complexity is abstracted away. Up until the point that in order to use a computer, you just have to turn it on, right? You hit the power button and then a lot of stuff happens. What happens under the hood? I don't know. Many things I don't have to know, because that's abstracted away. And abstraction is the most important things here as well, especially when we program something. So now I want to show you a lot of live code. Why? Because I think that's more interesting rather than to read slides. And in order to come up with some proper abstraction, and in order to show you the importance of that, let's start with something that typically we do not like to do very often. Let's start with tests. So I have a system test, or acceptance test that will test some application. I will show you examples using Java, or Java Enterprise specifically, but it's not much about programming languages even. It's much more about how to come up with proper design. Who of you uses Java? Quick poll, hands up. Okay, almost everybody. Okay, that's great. So you're familiar with the syntax. Other than that, it doesn't quite matter. What do I have here? I have a car system, right? So Germans like cars, so BMW, Mercedes, something like this. Assuming you have a system where you can communicate using HTTP, right? So somewhat REST interface, and now you want to create and order a car. And I want to test that in the system test. So this is what I'm doing here. Now imagine something like this. I have a test that is using JUnit. You've probably seen that. Create verify BMW car. Okay, and then it goes on and with very technical stuff already. So I use what is called JAX-RS for HTTP request. So I could, use any HTTP Java client here. I make some request with application JSON. You've probably seen something like this. And then I say, okay, what are the orders that are in the system? So I do, it's a little bit cryptic here. I do a HTTP GET request to read some JSON data and map this, into some orders. And then, of course, I want to create a new order. We see here will be a new order, BMW red. And then I create some JSON. Let's have a look at this method down there. So I create some, JSON request. Which brand do I want to order? Which color? And so on and so forth. And then we go back and it goes on and say, okay, in order to create that, we do an HTTP post request, right, using this JSON. So we're going to post some JSON to this resource. And, well, then we want to assert, okay, whether this was successful or not. So we will see whether this works, right? Imagine that's a part of a test. So we want to test whether that communication worked. And then we continue, okay, if that was successful, we get back the location of the new created car order. So then we want to see whether the information is correct, right? So we're gonna connect to that, again, using JSON and make an HTTP GET request and so on and so forth. So just a quick question. Did you understand that, like, right from the beginning? Okay, so you're very clever. That's good. Do you think that's very readable code? No. Is it obvious from just looking at that, what it does, what this method even does? I mean, it says create verify BMW and it says test. Okay, it's probably a test here, but it's not really readable. I guess we agree. And the method is not that long, right? It only has 29 lines of code. But the point, what is missing here, it does too many things, or not only that, it has too many different abstractions. So let's go back a little bit and imagine, okay, what should this method do? This method, that's a test, it should test to create a car. In this case, a BMW, red BMW, you read it here. And we want to test whether that works, if we have some system that is under test. Now, that's already it. And now you see it also talks about, JSON, it has some information about HTTP, it will see some HTTP status codes and assert this and that, and so on and so forth. It will compare some information, whether that is correct. But again, it has too many different concepts here and too many abstractions in this very method. Now, let's roll back a little bit and let me create just another, I call this now end-to-end test. Test create BMW. And now let me start over and just as comments, what we actually want to do here. So what would be a better idea? Again, this is not really readable and this is not really understandable, so let's roll back and start from scratch. What do we want to do? We want to test whether we can create a car, right? So something like, create car, right? Something like this with brand BMW and color red, right? This is the actual test scenario. That is the test code, the abstract scenario that we want to test. And then something like this, verify whether car order, so let's do something like this, save order, save car order, verify whether that order is in the system, right? Is in system with brand BMW and color red, right? Something like this. So that is the actual test that we want to do. And now we would like to implement that, but if we now add more information, or in other words, if we add more abstraction layers than what you read here, then it would become too complex. So what we do instead, we delegate to either another methods or into a delegate, into another class. And I've prepared something here, how this would look like, and now you see that is a little bit more readable. System test does the same thing, but now a different method. Create verify BMW, and we say, okay, what we do, create new order with BMW and color red. So what we say, new order, BMW red, and then we have a delegate that they call car order system, create order. Now, if you look at this, that's the exact same abstraction level than this, pseudocode, this comments, this human readable string. That's the same abstraction. I just say create car order red. Now the important thing is, how do I create it? Well, I don't know and I don't care. That's the part of the delegate. That is abstracted away. I'm not interested in that right now. So all of that lower level details, HTTP, JSON, status code, is abstracted away in this other delegate. And that's already the most important thing here. That is abstracted, and I don't want to create any leaky abstractions here. I don't want to know about JSON or HTTP, and how that is created is in the delegate. Then I ask again, okay, now verify whether it's in the system, right? So I read this car order again using this URI, using this identifier, and then I see, okay, is it now, does it contain the brand BMW, color red, and so on and so forth, and do all of my orders contain this, and so on and so forth. But the point is now, if I'm interested in how that is created, I look into this delegate. And this delegate that I call core order system, that has the information of the HTTP client, and it says, okay, how do I get the orders? Well, you make an HTTP request with JSON and so on and so forth, right? And how do I create the order? So all of that is abstracted into this delegate and into other methods. And now if you look back, well, this, of course, is much more readable. Right? It's just a few lines of code and you immediately see all the important information on this abstraction layer. So you see create car BMW red, verify in the system, done. How it is implemented, different delegate. And that is one of the most important principles here, how to come up with some more readable and some more maintainable code. So if you look into this abstraction, how did I come up with that? It's a method that I would call think first driven development. So if you start from scratch and if you want to implement, this system test, for example, well, ideally you start by thinking first, by writing in comments, pseudocode. I sometimes start even on paper. I just start from the very top, from the top abstraction layer. What do I want to implement here? Create a car with this and this information and so on and so forth. That's it. Don't talk about HTTP. I don't care about HTTP. If a user uses their app to create a car or whatever, they don't care whether it's HTTP. Most people won't even know about it, or JSON, never heard of it, right? They just want to create a car, and that is what we do here. And then how it is implemented, that is in a different layer. So in terms of maintainability, so that's another topic for testing specifically, or for any type of code quality. How do we come up with a maintainable code? Well, like this. Because if I go back to my previous test, imagine, right? Well, first of all, you cannot read everything before, well, you have to read it carefully, otherwise you don't see the whole information because it's too much code. But imagine now I want to, also implement how to create blue BMW cars. Well, then what happens, of course, you would copy-paste the whole thing, right? This is what we do. And then you look closely for this information and then you change red to blue, right? And then you end up with 60 lines of code, of test code, right? And then you implement not only BMW but Mercedes, and then you end up with 120 lines of code. And you see this is where you end up with not maintainable test code, right? And then imagine you change JSON to something else, to XML or to protobuf, right? What happens? Well, then you can throw away this class, right? Because you have to change every single line of code, something like this. Or same if you change HTTP to another protocol, right? If you do this in this class, though, it's much easier, because here, if you change HTTP to something else, well, this class is not affected at all, because this class doesn't know about HTTP. If you change JSON to something else, well, same story. Then you would only need to change that delegate, right? So imagine if you have many, many test scenarios of a lot of complex test suite or something, then you only need to change, well, what you actually, the single responsibility of the delegate that implements a certain thing. And that is the important part here. So this is probably one of the most important principles or important things to do in computer science, always to come up with proper abstraction layers and to care about, well, how these layers are crafted, and to care about that we don't have any leaky abstractions here, that we don't leak the details into the implementation here. So for example, in your test that you don't care about HTTP or don't care about JSON, trying to, stay on one abstraction layer at the time always. And it helps, to start from the top with this approach and then slowly dive into the details, how they're implemented. And, comments or pseudocode help a lot. So this is what I do actually all the time. All right. And another thing that came out from a discussion with actually a performance expert on the JVM, but totally different topic, but it's very much related. That person said, if you want your code to perform well, performance, how fast it operates, then delegate the hell out of your code. Why? Well, that has also implications on how the JVM operates in the just-in-time compilation. Because if you have small methods, it's much easier for the compiler, for the running JVM to hot swap them and to natively compile them on the go and things like that. So you also come up with more readable and maintainable code, right? So for example, how to create an order, well, send request. That again is already in another private method, right? Then verify. How do I verify it? Well, it's implemented in this method, right? And you come up with stuff that is really readable and tiny method bodies. And that is just helpful for actually both humans and machines. So that makes your code more performant as well. And as we saw, this is implemented in a different delegate in a different class. So that is to be said about abstraction. Now, a little bit different topic. You probably have heard of that, a domain-driven design. Who has heard of this term? Hands up. Who has even read the book, Domain-Driven Design by Eric Evans? Oh, only 3, 4? Okay. That's a good recommendation, by the way. So domain-driven design is, well, one somewhat a buzzword or a collection of a few concepts, how to come up with application code that matches the domain, your target domain. What is the domain? The domain is the actual business problem that you're trying to solve. That is the actual business case that you're trying to implement, right? You should implement something that solves a problem, right? That implements a use case in your domain. And that is how to design basically your domain, your target domain, what you're working in. And in domain-driven design, there are a few concepts or stereotypes that I want to explain, and we will see how to map that to Java specifically or to object-oriented programming. So, for example, the first one is entities. An entity is basically every noun, every word that we deal in our domain. So, for example, for this car application, an entity would be a car or a car order, right? An entity is something, all of the objects or the nouns or the things that we deal with in our application. And there are a few things here. For example, car. I created some car to regard. And this one is, first of all, just a POJO, right? Plain Java object with some properties here. And what is important about an entity, or what is actually distinguishes them from other things. So if you model your domain, then you think of these entities, these objects, as, well, identifiable objects. So that is the most important thing about an entity. We see here the car might be UUID or some serial number. It has an identification. So it actually matters which car we're operating with, right? It's the same with users. Users that sign up on a website, you can identify them. That's important, right? That's the important thing of a user. That's not true for all objects. So, for example, we also have value objects. That is the second thing. A value object is an object where I actually don't care about its identity. I just care about its values, right? What the properties are of an object. Let me give you an example. Here I have some money, 100 ruble, and here as well. So 100 ruble and 100 ruble, 2 bills. Technically, in a domain, this would be an entity, right? But I say, for me, it's a value object. Why? If I would ask you, do you want this 100 ruble bill or do you want this 100 ruble bill? And they're not fake, they're real money. So if I would ask you, do you want this or do you want that? Then of course your answer is, well, I want both, right? But if you would have to decide, well, then you don't care, right? Because one is as good as the other one. You only care about the value. So these can be seen as value objects because, that 100 bill is as good as the other one. Technically, they're entities. So the government who produces these, they care about the numbers. And if you look closely, they even have a serial number, Adin 0073 and so on and so forth. And this one has a different number, so they're different objects, they're different entities, and when you produce them, it's, I guess, important which number it has. But for us as a consumers, it doesn't matter. And it might be important or interesting for your domain whether something is a value object or whether something is an entity. And the question is mostly, do I need to care which object I'm dealing with, right? And in terms of money, I usually don't care. I only care about the value. I care whether it's 100 or whether it's 50 because that's the difference. But which bill, I don't care. So in this case, a car, and again, this depends on my domain. In this case, I say it's important which car I'm dealing with because of the maintenance, history, and so on and so forth. Let's delete this code for a second. That's just distracting. And the properties. So it might be a different thing, assuming I have a car engine, and I don't care about its properties, it's just for the example. In this case, the car engine, it's also an entity, it has a serial number. So for example, the car engine, a number is produced, and you might care about which engine it is, because it might also have a history of maintenance work and so on and so forth. I have some other properties here. I have some tires in a car. And then the tire, assuming this is a value object in my entity now, I define this now, so I don't care which tire it is, I only care about the specs of the tire. So in this case, I say the tire has a specific width and a specific speed rating. So that's how we identify tires, right? So there are different speed rating numbers. If you had a look at a tire serial number, right? I'm from Germany, so if you ever drive on a German Autobahn, then you might use this specification to drive very fast with your car. That's important, but other than that, you don't care which tire you get in this case. So this might be a specification for this car. And the biggest difference between an entity and the value object is whether it's, it needs to be identifiable. Now this comes with a few constraints or with a few side effects. So especially if you deal with a value object, and you can see this here, you can make the value objects immutable. And this then is, from advantage, because immutability, less bugs, it's a little bit more optimized to be used from your engine. And that's why I make all of these fields final. So in this case, final width, final speed rating, and I inject this into my constructor, and then it cannot be changed, obviously. And what is the outcome of that? I can actually now use references to one tire from multiple parts because it doesn't matter, right? Because the tires cannot change. So if you think of your domain, this probably would not make sense, but in your code, if you have one tire that has this width and the speed rating, you can have a reference to the same tire for multiple parts, and it does not break because the tires cannot change. The reference to a single object cannot change. Right? It's the same if you have a value object for an integer. Internally, your JVM, if you have integer 1, int1, it might be an object that is referenced for multiple parts. Same with string, right? String in Java is immutable. You cannot change a string. If you modify a string, you will get a new string that has the different value. And if you have a reference to the old string, it's still the same value. And in this case, what you can do, if you have multiple tires that are actually referenced from multiple cars, which doesn't make sense if you think about it, but in the Java world, it totally makes sense because a tire cannot change, and then the value and the outcome is the same, right? Same with the money, with the bills. If you have a 100 ruble bill, you can reference it from multiple sides. If the value does not change, and it cannot change, then that's totally fair. Now, if you work in enterprise software, specifically with Java Enterprise, who of you has used JPA, Java Persistence API, maybe with Java EE or with Spring? Yeah, a few of you. So the nice story about that is this matches quite well this model. Specifically, if you think about it, what is the name for defining, well, an entity? A JPA entity, the name is literally entity. So you annotate something with @entity, and if you further think about it, the definition of a JPA entity is also exactly this. JPA entity needs to have an ID at ID. That is the primary key in your database if you map this to persistence. This is now specific to Enterprise Java, but just to get that idea, because this modeling matches here really, really well, then this entity needs to be identifiable with a key. Now the same is true for the engine. The engine then would also be an entity. Now this is only pseudocode, this won't work, but that's fine for the example. Then it also has an ID. In the case of a tire, this tire is not an entity. This tire would be a value object, so I can make this into an element collection in JPA or something like this, where I have another table with just all the tires, but then it's not, the tire itself would not be reflected as a table. It would be something like, at embeddable, right? Something like this. And then it's just these values will be embeddable in this case, and then I can map this as well. Now, one thing you might have ran into if you're trying to map this into your domain, actually, unfortunately, you cannot have final values with JPA, because then it could not be created with reflection and with these dynamic frameworks. So one thing that helped us in projects is to make something what we can call effectively final. So for example, if we create a constructor with no args and make this even private, this works in some ORM frameworks, then if you think about it from the outside, this is now, it's not really immutable, it's not final, all of these fields, but it's effectively final, because from the outside of this class you cannot change the values here, right? You create a tire once, either using this constructor or load it dynamically from the database using reflection, and then it cannot be changed because you don't have setters, right? So that at least works as a workaround here for this modeling approach using ORM frameworks. So that's to be said about entities and value objects. Then a few more concepts here. So an aggregate, this is also an interesting concept from domain-driven design. This always describes an entity, so an aggregate is an entity that aggregates multiple entities or multiple objects, especially if you deal with some more complex domain. So a car, for example, is already quite complex. So a car is consistent of multiple things here. So a car consists of an engine, of some multiple tires, maybe some tank and some tank fill status and so on and so forth. And now if you say you want to modify the engine, then in this case, for the sake of consistency and to reduce the potential for bugs, you would always get the car first. You would always identify and load the car, and then basically transit through the car, get the engine, and modify the engine. So in this case, the car acts as an aggregate. You would look up the car from the database, and you would modify and then store the car accordingly. So basically, the car acts as an aggregate of multiple objects, right? Because the car has a reference to its engine, has a reference to its tires, maybe to some other things that might be entities or value objects, but it aggregates multiple domains here, multiple things. Factories might be methods or classes that basically create other things. They create entities or value objects. Just from experience, one thing that is interesting to mention here, what I deleted here before, let's make this back. Basically something like this. If you create, let's say, a maintenance work of whatever happened to your car, this basically creates a new, in this case might be value object, right? A list of some maintenance work, whatever whatever work has been performed on your car. Then this can be created using, and now this might come a little bit, this might be public, counterintuitive, using a method that resides within the car. Why? A lot of enterprise projects keep it very clean on, having a POJO that only has getters and setters and nothing else, and then you would create, something like a car service or a car maintenance log service that then uses this information. But actually from object-oriented programming, if you think about it, it makes much more sense, in this case, to create a method that already uses all of the information that is inside, that is contained in the car, and then offer this as another method. Even in mapping frameworks like JPA or something like that, that's not forbidden. Quite the opposite. That actually is a really good idea, because then it's much more concise, the logic, it already resides here in the car, and you don't have to spread it out to a different service, like to a different class. Because everything what I do here basically belongs to the car anyway. All of the data here in this example of the maintenance work is part of the car. So it makes sense to make this factory, to make this part of the car's API, to introduce a method here, right? To create the maintenance log just for this car. And the same is true for if we create something for services, right? So assuming, let's create a service. Assuming we have something like a car service, this is now very common if we deal with enterprise Java, right? Like Spring or Java Enterprise, we may have something like an add service in Spring or add component, right? Or add application scoped in CDI and Enterprise Java. And then we can have something like create car, right? So void method create car with some specification and so on and so forth. And it basically deals with, all of that information of, for example, creating a new car, right? So we have a car that is being created, which is now the entity. And then in this case, we, perform some business logic based on whatever's supposed to happen here, right? It might involve what is called a repository. That is an object to deal with, especially persistence, right? What is already a very sufficient repository is the JPA Entity Manager. Spring Data and Spring Data JPA also comes with repositories that actually are called repositories. So this is even more obvious on methods you can create yourself. So that's even more handy for us. And then we can do something like Entity Manager, merge car and things like that. And that is basically the implementation of that, handling with these entities here. I can look up cars by the identification. I can look up then engines if I take a car and then modify the engine and persist it again, and so on and so forth. So that's basically the idea. And now, again, it depends where I do want to put some information. And ideally, if I have some especially methods or use cases that I perform that use information that is contained in a single entity, then it might make sense to put this on the entity itself. So here's another example. I create what I call car tank fill service, where I fill the tank of a car, obviously, and then I say, okay, fill the tank of this car, right, and make it full. So I can say car, set the tank level here, because my car, that's another car, has a tank level, and of course, as always, I have a getter and setter, right? That's very basic code. So it works. I can say fill the car tank of this car, so it sets the level to, that should be 100%. This works, but if you think about it, actually I could get rid of all this information that I expose here and make it more concise by changing it to what I have here, to just a method that I call fill tank, right? So for a lot of use case information that only works with some data that is part of my entity here, I can rather expose a method like fill tank, and then I don't have to expose the tank level information, right? As you see here, I have no getter and setter here, or no setter specifically. I can just say, okay, now fill the tank level to 100%. So again, same principle, abstraction. I abstracted away the details, how the tank level is implemented using this double, into just the method, fill the tank, and that's it, if that is all the use cases I need. So I can get rid of, another service that implements it. So if I can put some logic into an entity class itself, then this might make sense. Like here, of this factory of just creating a new value object, or for example, of some information that otherwise will be implemented in a service class, right? So these are just a few examples how to model these information into, this Java and Java Enterprise for domain-driven design here. All right, let's go a little bit further up the abstraction levels, and specifically the architecture. Let's talk a little bit more about how to model specific projects and how to come up with a plan to make it a little bit more readable or a little bit more obvious. So I really like this term, screaming architecture. This was the name of a blog post by Martin Fowler. The idea behind that is that the architecture of whatever I have of my code should really scream what it is about, should really communicate, hey, I will implement this domain. So if you think about it, if you are in like architecture, like building up a building, if you look into what is called floor plan, that's the best way in English. There was a Russian term that I forgot, and in German it would be Grundriss, which is, well, I don't know, a better term to come up with. You look into a picture and it tells you how a building looks like. And if you think about it, if you look into this floor plan, into such a plan, even if you don't know much about the details of a building, you can probably assume or guess what it is about, right? So if you think of an apartment building and you look into the floor plan, well, you would probably recognize it's apartments, right? You have a big building, maybe multiple apartments on one floor. Every apartment has like an entrance, has a kitchen, has some bathroom, living room, right? And then another apartment with bathroom, living room. If you look into a store like a supermarket and the floor plan of a supermarket, you will probably have an idea of that this is a supermarket, right? You would look into it, there's like a big entrance and then some cashiers, and there might be, multiple like hallways, like going like a labyrinth where you can have shelves with some stuff on it. You would recognize that as well, right? If you have an event hall like this, you would obviously recognize it, right? You have a huge room with a lot of seat rows and then something like a stage here and a screen maybe. So just looking at a floor plan without knowing anything about the details, you don't know about the materials here, about what the stage is being built of, doesn't care. But you already know, okay, this is an event hall, this is an apartment, this is a supermarket, right? So in this way, it should scream at you, hey, I am a supermarket, right? So that is the idea. Now, if you put this into software, if you open up the source code of a project, it should actually tell you the same thing. Right? So not just the name, it might be called car application here, okay, that's obvious. By just looking at the code or looking at the structure first, you should see this. And what is the first structure that we see in Java projects? Well, these are Java packages or specifically folders, right? You open up the root folder, source main Java and Maven, right? And then you see probably company name and then you see some packages. And what we typically see, this might be a little bit too small for you here, so I opened it up here on the screen. What we typically, that's just a folder list under my application. We see some root packages like this, right? DAO, entities, exceptions, very important, REST services, something like this, right? So what does it tell you? Well, you have multiple technical layers. It's about DAOs, so you probably have some database or some persistence here. Entities, exceptions, okay, so probably deal with Java or with C# or something like this, right? It might even tell you, hey, I am a Spring application, I am a Java Enterprise application or something like that. But it doesn't tell you anything about what you're actually doing, right? It doesn't tell you anything about what the application is about. So that's much more important, right? If you look into the floor plan of a building, you don't care about whether it's concrete walls or wooden walls or stone walls. You care about whether it's an apartment or whether it's an event hall or something like this, right? So what you should rather look at is something like this, right? I say, okay, that's a package that's called assembly line. One is called cars, one is called maintenance, orders, quality control. So without knowing anything else, that's the first time we look at this application, you probably know, okay, this is about cars, right? Assembly line, okay, we probably produce some cars, maintenance, maybe some maintenance shop as well. Orders, quality control, so it's definitely about cars and creating them, right? Without knowing anything else. So it screams at you, hey, I am about cars. So that is about how to package your applications and specifically how to come up with that packaging of your Java packages, of your Java classes to scream at you to communicate what that is about, right? So that is what I care a lot about, that we basically slice our applications and organize our applications by business terms and not by technical terms, right? So we talk about assembly lines, this is car, quality control, maintenance. We don't talk about here are all Java exceptions and here are all Java JPA classes. I don't care about the exceptions, right? I care about implementing the business logic. And then the exceptions can be somewhere else or within all core exceptions might be here and something like that. So, craft that by the business layers first. So horizontally sliced rather than vertically, if you know that picture. And then store it accordingly. So in this case, well, I came up with some folders here. That's a little bit small to read for you. But basically, that is how I would organize a more complex application. And then it's very easy to see. And it's also very easy to actually modify and to change, right? So if you, for example, implement a new use case that deals with maintenance work, right, then it's very likely that you modify multiple technical layers within the maintenance folder. It's not very likely to say I don't know, modify all Java exceptions at the same time, right? That doesn't make sense, right? Why should you do this? So you usually modify multiple classes that belong to a very concise part of the application, to a very concise functionality here. And that is about this screaming architecture and how to specifically come up with an architecture that communicates the intentions well of the application. That is true for a single project that belongs to your code, and that is of course also true for the bigger landscape of your microservices or of your applications within your company, that you just communicate well what that is about, always starting from a business perspective, right? Always from the use cases, what am I trying to solve, which problem? I don't care about technology here, I don't care about whether this is a Java project, this is a Node.js project. No, what problem are you trying to solve? And then model accordingly. And then at the end we can talk about Java classes, right, if you want, and things like that. That is another very helpful concept from experience called YAGNI. You ain't gonna need it. Means you will not need it, don't do it. So every time when you try to implement something where you say, oh yeah, I'm now creating this super complex abstraction layer because we totally need to abstract that class because later on, you know, this might change and then we will replace this with another implementation, and just to be sure we create an interface that is implemented by just one class, but I'm pretty sure there will be another implementation later on and things like that. Premature optimization, don't do it. Keep it simple. You ain't gonna need it. If you say, oh yeah, we totally need this in a month from now, fine, then do it in a month from now, but not now. Keep it simple as possible, right? Don't try to be overly smart. Create very few levels of abstractions if you need them, but don't create empty delegates, right? A class that has nothing to do rather than just calling a single other class, but not implementing any logic, that doesn't make sense, right? Then you just create a lot of code for nothing and you create, you know, more tests and more stuff to do, more potential for bugs. Keep it simple. Delete code if you have to, and don't try to be overly smart, especially with coming up with proper abstractions. One method that I showed you before with this think first approach, that is helpful if you already deal with a certain complexity. If that is not already the case, it's very hard to come up with perfect abstractions right from the beginning. So don't even try to do that. Try to keep it very simple, and once something changes, then you can refactor and come up with better abstractions. Right? Specifically with interfaces, there's a saying that you need at least 3 different implementations to come up with a proper abstraction for an interface. If it's less than that, it might not be perfect. And then if you have another implementation, you would need to change and refactor it anyway. Right? So don't try to be overly smart in the beginning. Try to refactor later. Try to keep it simple. Implement proper testing, proper automation that you can change it later on. And it's more important to care about, you know, maintainability. So, you know, as you saw in this end-to-end test here, I implemented that using only 2 abstraction layers, right? One class for the test and one class for all of the nasty details. So here, system test, that is very readable, and the core or the system is kind of readable. If this would be more complex, then I would introduce another layer of abstraction, right? Another maybe class for JSON handling, maybe another class for HTTP, something like that. It becomes if it becomes more complex. But if not, just leave it as that. Don't try to be overly smart in the beginning. You ain't gonna need it. That is just from experience helpful in projects. And let's talk a little bit about these solid principles. You might have heard of them. Depends whether it's very, very important or not in projects. Just for you to, if you have not heard of them, solid principles are 5 principles for designing or, you know, how to come up with a code quality. First one, I think, is very important, single responsibility principle. That means one unit, and mostly one class or a method, should have one responsibility, or a much better description, one reason to change, right? So if something happens to that class or to that method, you only should have one reason to change and not multiple reasons. If you have multiple reasons or multiple situations where that class could change, then it's doing too much, or again, it has too many responsibilities. For example, this again, I said this before, this test from the beginning, it has multiple reasons to change, many reasons actually, right? So what happens if my test scenario changes? Create not red BMW, but blue BMW. Then this class or this method has to change, right? That's already one. What if JSON changes to something else, XML? Well, then this method also has to change because it deals with JSON, another reason. What if HTTP changes to something else? Well, another reason, and probably you can think of 3 or 4 other reasons. This is too much for this method. But as you saw in the other refactored system, this pretty much only has one reason to change. Well, what if my test scenario changes, right? Red BMW to something else, silver Mercedes, something like that. This class doesn't have that reason to change. It only, it doesn't care if the test scenario changes because that's outside of the scope of the class. But it cares, well, in this case, as you already see, maybe if JSON or if the HTTP communication changes, then 1 or 2 reasons. So again, this might be refactored into another one, but it doesn't, at least doesn't, is not coupled with the test scenario here. So that is rather important. Open-close principle means a unit or component should be closed for modifications and open for extension, open for additions. I think a good example is a smartphone with the functionality that you can add in app stores, right? So if you download a new app, it basically extends your phone with some functionality, but hopefully it doesn't change the functionality of another app, right? So if you download WhatsApp, it should hopefully not change the functionality of Telegram, right? You still expect the Telegram app to work in the same way, rather than you add WhatsApp and then everything else is different. That would confuse you, right? So think of it in this way, and basically, well, if you modify something, it should not have any side effects here. If that is the case, you need to refactor or change your design. Kind of important, I would say. The third one is also kind of important, important in terms of that you would notice or that you would be confronted with it in real-world projects, from my experience. Liskov substitution principle basically says if you model classes and specifically hierarchies of classes, then you must be able to replace a parent's class with a child class with a inherited class and its implementation. So in other words, if you change, car with German car or fast car, and then the fast car should not should not break the contracts of the car. So if you say car drive and you expect the interface or you expect the implementation to behave in a specific way, following the contract, then the substituted car must behave, in the same way or must behave with the same contracts in mind. Right? Otherwise, you have some side effects and then some unwanted behavior there. Interface segregation principle also kind of important. Depends on how complex your scenarios are. Means if you have interfaces like Java interfaces, then you should rather keep them small and just with a few methods or just with a few responsibilities, rather than having single big interfaces that tries to accommodate everything that is just coupled to a specific service. Depends whether that is. Just from my experience, most of the code is not that complex that you have this much hierarchy in most of the application code. Dependency inversion principle, that's also more like a guideline for modeling in general. That means you should not be dependent on implementations. I think that is already, or again, a good example. So you shouldn't be here in this case, dependent on the implementation, which is the case here. We are dependent on JSON, we are dependent on HTTP. You should rather, try to inverse that dependency of saying, okay, we're just dependent against abstractions. Oh, where's my other system test? And the abstraction here again is this core order system that just says create order. So this is the abstraction, this is the contract if you want, just calling this method, and then the implementation is somewhere else. I also saw the image of a power plug, and that's also a very good abstraction, right? A power plug, at least within a single country, you can just plug in whatever you like. It doesn't matter if it's a lamp or if it's a computer, if it just follows the same specification, And the specification is, the shape and size of the plug, and 220 volts and so much amperage, and that's it. And then you don't care whether it's a computer or a lamp. You don't want to be dependent on that details. That is pretty much that principle. Another thing, comments. Code comments specifically, and well, when they're helpful. So you should not comment obvious things, and I don't know, I mostly see two extremes, either too many obvious comments or comments that are outdated, or no comments. Both is depending on your code, right? So if you have something like, where's my end-to-end test? If you have something like, I don't know, right? This, or even better. So this is very enterprisey. Something like this, right? Great. It just clutters up your code with a lot of stuff, but fortunately we have IDE features, so I can get rid of it. But the problem, of course, is either, well, it's just obvious, right? Captain Obvious, it doesn't tell you anything, or it's even wrong, that's even worse. So if code changes, then nobody changes the comments, and then, that's just misleading, and you don't know what is true. And, well, mostly what I see in comments, what you can do, if you have something like, there's a nice saying, put the what into the names, put the how into the code, and put the why into comments. And sometimes it's so obvious that there is no why, right? So it means put the what into your name. What are you dealing with? Well, put this into a name of a method or into a name of a variable. So if you say, returns 3, okay, that is stupid. But if you say something like calculate, I don't know, fill tank, and then you have 3 times something else, point, I don't know, something like this, then instead of that, what you should do is saying, okay, rename this method into, just get rid of this, into, well, the name, right? Calculate fill tank, I don't know whether that makes sense, and then you can get rid of the comment, right? So that is the what into the name. The how is, well, in the code, so you see how that is calculated, and then sometimes you have a why, right? So sometimes you need to explain, okay, why are we doing it this way? And then it helps to comment that, right? So comment intentions, comment reasoning for that, right? If you have some discussions with your colleagues, okay, why should we do something in this and that way? And this outcome is very valuable, because I guarantee you, in 2 weeks from now, you don't know why you did it. Even if you did it yourself, you have no clue. It's 2 weeks ago, it's in the past, we don't remember, or at least I don't remember. So put that into some documentation. Might be documentation, or might be a comment, and then we did it this way. We did it this way because, and so on and so forth, right? So that is helpful for comments. Other than that, it should not be obvious, right? Don't comment obvious things. So might be helpful to comment a class, might not be, depends on the case. You should not be overly strict with comments, so don't try to enforce comments like JavaDoc on each and every class. It just forces people to, do auto-generated stuff like I did before, and that's just, it has zero value. It just clutters up your code. So that's what is said to be comments, about comments. What helps me a lot, what I showed you before, that I started writing this end-to-end test in comments, and then I replace the comments with actual methods. And then I use the value, what I write in the comments, as method names. This is very helpful because, you think about the correct abstractions right from the beginning, and then you say create car, creates car with this and that. And then you, okay, call the method create car with this and that. It's very obvious, and you can delete the comment because it's already written in the code. And then, you come up with very readable and maintainable code. I think that's just a helpful for principle, and you can get rid of, unusable comments here. So as some key takeaways, in general, and that's probably the most important thing, try to be pragmatic and solve the business problems, right? Don't get hung up in technical details. I know as programmers, we like to program. It's fun to care about technical details. It's interesting. We could spend hours writing some, I don't know, HTTP, whatever, logging framework, some cool technical stuff. But that doesn't improve the world, right? We are there to solve a problem. We are there to implement some solution and to get some working code. can sometimes be very pragmatic if it works, depends on what you're trying to do. Trying to keep a proper design though, but don't try to be overly smart or over-engineering if you don't have to. Then, other than that, most important thing, try to come up with proper abstraction layers. That is already, if you do this, then you already won, right? Doesn't matter which implementation you use or even which programming language, right? Doesn't matter. If you come up with proper abstraction layers, proper classes, proper methods, this helps you the most. Then you come up with maintainable code, you come up with readable code, code that others understand, and that's just, it's the best win for design in any way. Starting from the very top, how to, properly abstract something and then dive in deeper. That's the easiest way to start from a top abstraction layer and then dive into if you have to. If you don't have to, well then don't try to create too many layers. If it's very simple, try to be pragmatic then. Don't try to fit something into some architectural guidelines if you don't have to. But, try to be pragmatic and have proper abstraction layers. Then favor immutability if you can. That's always a good principle, especially if you deal with a lot of value objects like we had here, or at least effectively immutable, if you have some technology framework choices here. Avoid leaky abstractions when trying to come up with some proper abstractions or some proper contracts. We saw this example of the testing, and I like to show this example of the end-to-end test here, because test code is very typically does not have a good quality, right? Because with test code, right, it's not production code, we don't really care. But with test code, it's actually very important to come up with maintainable and readable code. Otherwise, you know what happens. Then people just copy-paste something, and then you end up with many, many lines of code here. And if something changes, this is the problem, then you basically have to throw away your test code because it's not maintainable. Or, well, you end up with a project that is then not really tested. This think first principle helped me a lot with coming up with solutions on paper first, or code comments, pseudocode, put them in the right location, and then just implement them later on. As from the beginning, you down there as you dive in deeper into these abstraction layers and into lower level details. Another thing, you ain't gonna need it. Related to be pragmatic, to whether you need something or not, again, in order to solve the business problem, the business domain, always keep that in mind. That's what we are paid for. And yeah, it's much more important, I think, to care about design approaches, especially about these abstractions, rather than technology choices. So I showed some, Java enterprise code here. If you do Spring, you probably know it, you have a few different annotations, but the difference is not much, right? You can use the same classes, you swap out some tiny details. If you care about a proper design first, you could even, probably switch the programming language if you want, right? C# or Java is kind of closely related, you swap a few things, design might be the same. So that's, in my eyes, more important in order to come up with maintainable code and code that is readable and understandable. And that's probably the most important thing, to be able to write code, not only that can be executed and read and understood by computers, but that can be understood by humans. And that's more effective, and ultimately that's also more fun to create, I think. So I have some more resources here, especially books, if you like to read. I can recommend all of them. Also, shameless plug, I included my own book, Java Enterprise, Java EE, Jakarta EE, and all of the other books are very good reads, especially with Java, but with enterprise software in general. Other than that, spasibo большое, and thank you very much for your attention. So, yes, we will have some coffee break. And some questions. We can do some questions, yes, now and then coffee break, please.
Hello, my name is Sebastian. Did you skip last principle of solid dependency inversion principle intentionally? Or
What do you mean, skip?
you forgot about dependency inversion? Or
Did I not talk about it?
no?
I think I talked about it, and this was about what you depend on, that you should be dependent on the abstractions and not lower level details, right? That's what I briefly said with the, what I explained with the test, right? That you should not be dependent on this JSON and HTTP thing in your system test, what I had here, rather than be dependent on just the abstraction that I created. I just briefly talked about it. So again, Here in this poorly designed method, you are dependent on HTTP, you are dependent on JSON and things like that, and on the test details. In this refactored test, you are only dependent on this delegate, which is an abstraction. So it abstracts away the lower level details, how to create a car, HTTP, JSON, and things like that. And then, you kind of inverse the dependency of not on the lower level details, but on an abstraction, like a contract. This is what I said with the power plug. You basically then are only dependent on this, the plug form it's there. And 220 volt and 16 amperage and things like that, you're dependent on that, but you're not dependent whether you are operating a computer or you're operating a lamp, right? So that's basically this principle. Yep. Any other questions? Yep.
Hello, my name is and I wanted to ask, everyone is very lazy sometimes, also when you try to make a review of some code.
Yes.
Lines of code or too complex code?
Yeah, too much. Yes, so some tools, what I find quite helpful is the scenario cube analysis, specifically the analysis for cyclomatic complexity. So I think this tells you, this is probably the best metric or number that can tell you whether something is, too complex.
Yes, I already tried, but I also want to know if there's some possible scenario that can introduce some rules for every developer.
Yeah, so it depends a little bit. I know where you want to go. So if we talk about complexity, then mostly, sometimes we talk about actual, dependencies like HTTP or JSON, and then I could, for example, analyze something like the import statements, right? Whether I import a lot of stuff with different layers or different frameworks. But mostly I talk about abstraction, which is my own code, right? So if I say, okay, a method does too many things, has too many abstractions, and abstraction is it's a made-up concept. So the compiler cannot necessarily tell, okay, this is a different business code abstraction because the compiler doesn't know about your business use case, right? So you could come up with some rules. I think a good rule is maybe like different packages that you include in your class, right? If a class imports a lot of classes from different packages, right, like with the packaging approach that we saw before, then it might have some multiple abstractions already. And if that class also has a high cyclomatic complexity, then it might be dangerous. Or then at least you should, fire up a red lamp to say, okay, hey, look at this. This is some kind of hotspot in your code, and then you might be able to identify these parts. So I found the cyclomatic complexity quite helpful, but of course not always, right? If you deal with some sophisticated algorithm, it has just a high complexity, but it might be, a good idea to stick that into one class. So it depends a little bit.
Maybe it depends on your own expertise, and sometimes after several years you become more accurate when you write code. Yes.
That definitely, yes. And the question is just whether you can come up, your question whether you can come up with an automated approach that detects that. It depends. It might be a little bit challenging if you,
Because I want to have maybe a lot of interns.
Yep.
And I want them to write a good code.
Yes. If you want them to write good code with first time, I would say the best thing is to teach, and especially by examples. There's also good, I think I included it, a good book on Java by comparison that I enjoyed that. So it basically shows you two classes, like a little bit what I did with the end-to-end test, right? Showing the properly designed or a better designed approach and one poorer approach, or we don't have to judge one approach that uses multiple abstractions, one that doesn't. And even if you have a less experienced programmer, they probably would agree that you say, okay, this is less readable than this, right? And then you explain them, okay, what I did here, I have multiple responsibilities in this class, so I included some abstraction, for example, right? So this might be one example.
So we still have to do it by ourselves.
Well, you teach them once, and then they hopefully know better, and then you have to deal with less in the future. Yeah, so that's the best answer I can give there. At least there's not, as far as I know, that there's not an automated approach to just detect something like this. There are some pointers and hints, like cyclomatic complexity, that might point you to some directions, but right, there's no AI for that case yet. Yeah, please.
all, thank you for your presentation. I have a question about what modeling tools do you use when, for example, you want to create a class diagram? Do you draw it in some modeling tool and then convert it to Java code, or you just write the classes inside the IDEA or something else?
Which modeling tools? So that's just me. I sometimes use pen and paper. I like whiteboards because you can erase them fast, and other than that, I mean, that's the honest answer, not much. I'm not a big fan of code generation tools because they typically, depends on the framework or technology you use, they never come up with 100% what you need, right? And then, you need to modify that anyway. Sometimes in bigger projects, when, you create some very big class diagrams first, and then you might have a case where it's faster to initially create the Java code and then modify it still, so just for the first creation. There's some IDE tools, so in this case I would use some IDE modeling like IntelliJ. But other than that, or to be honest, I'm also not a huge fan of UML syntax, right? Some people get hung up on, how to draw this and that arrow, whether it's this one-to-one relation or not, and I'm like, actually I don't care that much. I mostly draw boxes and arrows or just dependencies, or sometimes, how to implement a class, and other than that, I think just boxes freely drawn explain more than super sophisticated UML, because it doesn't help you that much, from my experience at least, right? You never get 100% match from something that you can draw into your actual code. You always have to somewhat modify it, and this is where then, you can just draw it just for the understanding. That is very, very helpful. Draw diagrams in order to communicate, and not just in order to document, it's rather than a communication even. So if I draw, hey, you have some solution, okay, let me draw it. And then you're like, no, that's not the solution, and you change the drawing. So while we are communicating about how to design something, this is very, very helpful. But then, you don't come up with every tiny detail, it doesn't matter. You just draw the name of a class and say, car has an engine, has tires, has this and that, that's it. And whether this is private or this is, one-to-one or multiple, that at this level typically doesn't matter yet. And then, you can talk about this later. So to care about the responsibilities of multiple classes first and the hierarchies, I would say just whatever is the fastest thing to communicate. And typically that's pen and paper or whiteboard or some, easily draw mechanism. That's what I use at least. Any other questions? Okay, then you can think of more questions while we do the break. Maybe ask them later then, and let's have some coffee. So, thank you.